Okay, so in our previous two videos, we've introduced the idea of a polynomial function, what that is. We've also practiced working with function notation a little bit, which is sort of important when we work with polynomials. It's important with all functions, but we're going to use it a bit more with this kind of function. And then in the previous video, we introduced the idea of, or the process of polynomial division. Now, dividing polynomials is a really important technique in order to enable us to factorize a polynomial, and we need to be able to factorize a polynomial in order to be able to solve a polynomial, and we would need to be able to solve a polynomial in order to find the x-intercepts of the graph of a polynomial. So we're gradually building up the tools that are ultimately going to allow us to get to the point where we can solve equations and sketch graphs, which is what we want to be able to do for all of the function types we're going to be introducing. Okay, the next part of the puzzle, so we need to know how to do polynomial division. Before we can factorize, we also need to be able to use or understand the remainder and factor theorems. Okay, so we're going to work through an example here, which is going to illustrate what happens, and then I'm going to go through a little proof. So the first thing we want to do is we've got this polynomial, it's a cubic polynomial, x cubed minus 4x squared plus 7x plus 10, and we want to find the remainder when x minus 2 is divided into p of x. Okay, so we're dividing x minus 2 into p of x, which is x cubed minus 4x squared plus 7x plus 10. So if you want to give yourself a little test and do a bit of revision at this point, I would suggest pausing the video right here and practicing this division to see if you can remember how to do it from last lesson, and then resume and see if you were able to do it correctly. Okay, so if you've hopefully had a go already and you're coming back to check that your answer's right, the first thing we would do is we're looking at what do I need to multiply x by to get x cubed, or what do I get when I divide x cubed by x? How many times does x go into x cubed? Any of those questions are all the same thing, okay? And that is x squared, okay? So I need to multiply x by x squared to get x cubed. Then once I put something up the top here, I take that, I multiply it by x minus 2, and it goes down here. So I get x cubed minus 2x squared. And these should match. That's the whole reason I chose to put x squared up the top. If they don't match, x squared is not the thing that should go up the top. Okay? Okay, then once we've got that, we subtract. And that's where the x cubed should cancel out when we subtract. That's how we've designed it. We get negative 4x squared minus 2x squared. So that's negative 4x squared plus 2x squared, which is negative 2x squared. And then we bring down our next term. And then we repeat the process again. What do I need to multiply x by to get negative 2x squared? That's going to be negative 2x. Then once I've got negative 2x there, I'm going to take that, I'm going to multiply it by x minus 2, and I'm going to write it down under here. That's going to give me negative 2x squared plus 4x. Alright, and then we're going to repeat. So then we're going to subtract and then we're going to repeat. So negative 2x squared minus 2x squared, they make 0. That's the whole point. That's how we designed it. 7x minus 4x gives us 3x. And then we bring down our next term, which is plus 10. And then we repeat the process again. What do I need to multiply x by to get 3x? That's going to be 3. It goes up the top. Then we take that 3, we multiply it by x minus 2, and we write that underneath. So we get 3x minus 6. And then we subtract 3x minus 3x, they cancel out, that's the point. 6x minus 6 is 6x, 10 minus 6 is 10 plus 6, which is 16. That there is our remainder. So the question asked us, find the remainder when x minus 2 is divided into p of x. And we find that the remainder is 16 by doing the division. Okay, separate question, part B, same polynomial still. We want to evaluate, we want to work out what p of 2 is equal to. So p of 2 is equal to 2 cubed minus 4 times 2 squared plus 7 times 2 plus 10. And that's 8 minus 16 plus 14 plus 10. So 8 minus 16 is negative 8. Plus 14 is positive 6, and plus 10 is 16. Okay, this isn't a coincidence that these two things give us the same thing, okay? That P of 2 seems to be giving us the remainder, okay? Now remember, it's the remainder when we divide it by x minus 2. And what we found is when we subbed 2 into the polynomial, it gave us that remainder in a much more efficient way than having to actually do the division if all we're interested in is the remainder. Okay, now this isn't a coincidence, this is actually a fact. So let's have a little look at this. So this is something called the remainder theorem. When we take a polynomial, p of x, and we divide it by x minus k, just as we divide it by x minus 2 up here, in this case k was 2, the remainder is given by p of k. Okay, now the way we work out what do we need to sub into the polynomial, you're essentially taking your factor, the thing you're trying to divide by, and working out what would x have to be to make that factor equal 0. Okay, so x equals k, you sub x equals k into your polynomial, and you're going to get the remainder. Let's have a look at a little proof of this. If you're not able to follow the proof fully, that's okay. You can take it as rote, but it's just showing you one example doesn't prove the theorem. So let's have a look at the proof, and you should be able to follow the algebra of it. So in the previous video, we know that we looked at this sort of format. So we know that when we divide a polynomial by x minus k, okay, so when you take a polynomial and you divide it by x minus k, you get a quotient, which is what we end up with up here, and you get a remainder down here. And in terms of expressing that answer, p of x divided by x minus k is equal to the quotient plus the remainder over x minus k, which is what this is saying here. Okay, so we looked at that last lesson. We also looked at the next step, which is to say that if I decide to multiply both of sides of this equation by x minus k, okay, multiplying the left-hand side of the equation by x minus k is going to get rid of the fraction, and we'll just get p of x. Multiplying the right-hand side of the equation by x minus k is going to give me q of x times x minus k, and then multiplying the fraction by x minus k is just going to give me r. Okay, so these two equations are the same thing. Alright, so we know that p of x is equal to the quotient multiplied by x minus k and then plus any remainder that we might get. Now, if we were to let x equal k, which is what we're saying we need to do if we want to work out the remainder, we need to sub x equals k into the polynomial. So we get p of k, okay? Which means we're going to sub k in place of all the x's. So it's q of k, k minus k. Okay, so that was where our x's were in the original. Okay, so we've taken the x's up here and replaced them with k's. Now, interestingly, when we do that, we get, this is important, k minus k gives us 0. And so we've actually got that p of k is going to be q of k times 0. Well, q of k times 0 is just 0 plus r. So we just get left with r, which means that when we substitute k into the polynomial, it ends up just equaling r, the remainder. Okay. Now, as I said, how do we decide what we need to sub into the polynomial? Well, that's all about what would make this thing 0. Okay. What's going to make x minus k 0? X minus k will equal 0 when x equals k. Therefore, I sub x equals k into my polynomial, and I get I'll get the remainder. Okay. Now, an extended question from that is, okay, well, what if I had a more complicated? What if I was instead, what if I had p of x and I was dividing it by a more complicated factor, like ax plus b, okay, 2x plus 7 or 3x minus 5 or whatever it might be. Again, we know we would get a quotient and we'd get a remainder, which we would write as the remainder over the dividend, which was ax plus b. Then if we multiply everything here by ax plus b, we're going to get p of x equals q of x times ax plus b plus the remainder. So if we want to work out the remainder, we need to know what's going to make that equal to 0. Okay, so when does ax plus b equal 0? Well, that's when ax equals negative b, and that's when x equals negative b on a. So if we were to substitute negative b on a into the polynomial, that would make this bracket 0, and therefore all of that would disappear, and that would give me the remainder. Okay, so it's about solving your factor equal to 0 to work out what do I sub into my polynomial, and when you do that, that will then give you the remainder. Okay, so we extend that out to this more general remainder theorem. So if we're dividing by x minus k, we sub k into the polynomial. If we're dividing by ax plus b, we sub negative b over a into the polynomial. And that is found by solving ax plus b equals 0 to work out what goes in there. Okay, similarly, solving x minus k equals 0 will tell us what x value we sub into the polynomial. Okay? Okay, so let's use that. So without dividing, find the remainder when x cubed plus 3x squared plus 2x minus 7 is divided by x minus 2. Okay, so we know, that when we're dividing by, x plus 2. We know that when we're dividing by x plus 2, the remainder will be equal to p of something. We can sub something into here, and the thing that we sub into here will be the thing that makes x plus 2 equal to 0. So that'll be when x is negative 2. So if we substitute negative 2 into the polynomial, that will give us the remainder. So let's do that. That's going to be negative 2 cubed plus 3 times negative 2 squared plus 2 times negative 2 minus 7. So negative 2 all cubed is negative 8. Negative 2 squared is positive 4, so 3 times 4 is 12. Minus 4 and minus 7. So we've got negative 8 plus 12, which is 4, take away 4, which is 0, and then minus 7. So the remainder, when we divide by x plus 2, is equal to, when we divide this polynomial by x plus 2, is negative 7. So if we were to do x plus 2, divide that into whatever it was, x cubed plus 3x squared plus 2x minus 7, all the way down the bottom here, we get negative 7 as our remainder. Okay, so we want to be able to think about being able to work out the remainder without having to actually do the division. And in a minute, I'll talk about why the remainder is important. Okay, all right, so let's again just, without doing the division, find the remainder when 2x cubed minus 9x squared plus 17x minus 16 is divided by 2x minus 3. Okay, so the remainder, we have to work out what we need to sub into our polynomial to find the remainder, and it will be whatever makes that 0. So that's when 2x equals 3, so when x equals 3 over 2. So we're subbing 3 over 2 into our polynomial. And when we do that, we get 2 times 3 over 2 squared minus 9 times 3 over 2 plus 17 times 3 over 2 minus 16. Okay, so sometimes there's going to be a bit of fraction work, but actually, if we were to try and do this division, there'd be a bit of fraction work in the division as well. So I'm just going to get that out of the way, just it's getting a bit crowded. Okay, so we've got 3 on 2 squared. Sorry, that's cubed, isn't it? Sorry, that should be a cubed. There should be a squared on there. 3 on 2 cubed. So 3 cubed is 27 on 2 cubed, which is 8. Minus, we're going to have 9 times 3 on 2 squared. 3 squared is 9 and 2 squared is 4. Plus 17 times 3 on 2, so it's 17 over 1 times 3 over 2, so it's 17 times 3. 10 3s are 30 and 7 3s are 21, so 17 times 3 is 51 on 2, and minus 16. Okay, so rather than doing 2 times 27, we recognise that the 2 cancels down with the 8, and we're going to get 27 on 4. Minus, okay, this time the 9 doesn't cancel down with the 4, so we're going to have to do 9 times 9. It's 81 on 4. Now, we've got 2 fractions with a denominator of 4, so while we're at it, let's write everything else over 4 as well. So we're going to have plus 51 on 2 is 104 on 4, and 16 is, 4 16s are 64 on 4. Okay, so let's see what we've got here. So we've got, and again, you might look to sort of group things, 104 minus 64, well that's 40 on 4, so that's going to give me 10, okay? And this, what have I got here? 27 minus 81, you could think about that as 81 minus 7 and then make your answer negative. 81 minus 27 and then make your answer negative. So again, being flexible with your arithmetic here, okay? So let me think, 81 minus 27 is 56, I think? 54, sorry, hold on, let me do that again. Gets me to 61, and then take away 7 gets me to 54, sorry. So it's 54 on 4, and then this is going to be 104 minus 64. As I said, that's 40 on 4. So together there we've got 90, sorry, it's like 94 on 4, which if we halve the top and the bottom there, that's 45, 47 on 2. So my remainder would be 47 on 2. Sorry, I just realised I made a mistake. So remember, it was 27 minus 81, so that should be negative 54 on 4, which means, even better, we're getting negative 54 plus 40, which is... Oh, no, I've done it the wrong way around again, haven't I? Okay, so I've made really hard work at this because I've realised another error. 51, when we doubled that, shouldn't have been 104, it should have been 102. Hopefully you've been screaming at me while you've been watching the video. Apologies, as I said, it's actually quite late. Alright, so now it's 102 minus 64, which is not as nice, so anyway, that's okay. I was liking the 104 minus 64, so 104 minus 64 was 40, so 102 minus 64 will be 38 on 4. Okay, so we've got negative 54 plus 38, which is going to give us negative 16 on 4, and so we get negative 4. Okay, we got there in the end. Okay, so the remainder, when we divide the polynomial by 2x minus 3 is equal to negative 4. Okay, this is the kind of problem we might see to test our understanding of the remainder theorem. So when x cubed plus 3x squared plus 7x minus b is divided by x minus 2, the remainder is 20. Find the value of b. Okay, so we know that the remainder, in this case, would be equal to p of 2, and we know that equals 20. Okay, so p of 2 is 2 cubed plus 3 times 2 squared plus 7 times 2 minus b, and we know that equals 20. So we now have an equation that we can solve to find what b is. So if there's an unknown value in the polynomial, and if we know about a particular remainder when we divide by something, we can then find that unknown value. So it's 8 plus 2 squared is 4, 4 times 3 is 12, plus 7 times 2 is 14, minus b equals 20. 8 plus 12 is 20, plus 14 is 34, minus b is 20, and so negative b is negative 14, so b is 14. Okay, so if b is equal to 14, p of 2 will equal 20, which means that when we divide the polynomial by x minus 2, we get a remainder of 20. Okay, now we want to extend the remainder theorem into the factor theorem. So we know that something is a factor of something else if it leaves no remainder. Okay, so 5 is a factor of 20 because we get 20 divided by 5 equals 4 with no remainder. 7 is not a factor of 20 because 20 divided by 7 would be 2 with a remainder of 6. Okay, so not a factor is a factor because the remainder is 0. That's the point. So if we want to identify something as a factor of something else, which is important given what we're trying to do is factorize at some point, we want to be able to find when we'll get a remainder of 0. That's what we want to know. So the factor theorem is exactly the same as the remainder theorem, but x minus k will be a factor, which means we get remainder equals 0 if the remainder, which is p of k, equals 0. Okay, so x minus k is a factor of p of x if p of k, so remember p of k is the remainder, if that's equal to 0. Similarly, if we're dividing by ax plus b, we calculate the remainder by working out p of negative b on a, and if that's 0, then we can say we have a factor. Okay, so it's all about when does the remainder equal 0. So use the factor theorem to determine whether x minus 2 is a factor of x cubed plus x squared minus 10x plus 8. Okay, so we know that the remainder would be found by working out what p of 2 is. So that would be 2 cubed plus 2 squared minus 10 times 2 plus 8. So that would be 8 plus 4 minus 20 plus 8. Now 8 plus 4 is 12, plus another 8 again is 20, and so you've got 20 minus 20, so you get 0. Okay, so therefore, since the remainder is equal to 0, x minus 2 is a factor. Okay, Alright, so work out whether 2x plus 1, use the null factor theorem to determine whether 2x cubed plus 5x squared minus 28x minus 15 is divisible by 2x plus 1. So that's another way of talking about something being a factor. Okay, 20 is divisible by 5 because 5 is a factor of 20. Okay, so if this polynomial is divisible by 2x plus 1, that will be because 2x plus 1 is a factor. So again, we want to work out, okay, what remainder do we get when we divide by 2x plus 1? So remember, we're thinking about what will make that equal to 0. So 2x will equal negative 1, x is negative 1 half. Okay, so to get our remainder, we're going to sub negative 1 half into our polynomial. And then if that gives us 0, then yes, it's divisible by 2x plus 1. If it doesn't, then it's not divisible by 2x plus 1. Okay, so p of negative a half is going to be 2 times negative 1 half cubed. Let's see if I can get my arithmetic a bit more accurate this time around. As I said, sorry, it's a little late after a long day of online teaching. Okay, so let's see what we've got. So we've got 2 times, so negative 1 half cubed will be negative 1/8. Plus negative 1 half squared will be positive a quarter. And then we've got minus 28 times minus a half, so that's positive 28 times a half, so that's positive 14, and minus 15. Okay, so this is negative 1 quarter plus 5 quarters plus 14 minus 15. 14 minus 15 is negative 1. Negative a quarter plus 5 quarters is 1, minus 1, and so we do have 0. So therefore, since the remainder is equal to 0, 2x plus 1 is a factor. Okay, we could also write, rather than remainder equals 0, p of negative a half, that is the remainder, equals 0. Okay, again here we could say p of 2 equals 0. So because p of 2 equals 0, that means the remainder equals 0, and therefore x minus 2 is a factor. Here, because p of negative a half equals 0, that means the remainder is 0, and therefore 2x plus 1 is a factor. Okay, again, let's think about using that in reverse. Okay, so we've got an unknown coefficient here in this polynomial, but we know that this polynomial is divisible by x plus 1. Okay, so that means the remainder is going to be equal to 0. So the remainder is going to be p of negative 1 in this case, and that will be equal to 0 because it's divisible by x plus 1. Alright, so then let's work out what p of negative 1 is. So it's 2 times negative 1 cubed minus 3 times negative 1 squared plus a times negative 1 minus 3, and that's going to equal 0. We should be able to now solve this equation to find a. So negative 1 cubed is negative 1, and that times 2 is negative 2. Negative 1 cubed, negative 1 squared is positive 1, and that times negative 3 is still negative 3. A times negative 1 is minus a, and minus 3, and that's going to equal 0. Okay, so what have we got over here? We've got negative a, and we've got negative 2, minus 3 is negative 5, and minus 3 again is negative 8. So negative a equals equals positive 8. Actually, that's silly. Let's just add a to the other side. So a will equal negative 8. So if this value here is negative 8, this polynomial will then leave a remainder of 0 when we divide by x plus 1, and so it's divisible by x plus 1. Okay, let's see if we can put those two things together in a couple of slightly more complicated examples. X cubed plus ax squared plus bx. So this time we've got two unknown coefficients, which means we're going to need two bits of information to make two equations that we can solve simultaneously. Okay, x cubed plus ax squared plus bx minus 12 has a remainder of negative 18 when divided by x minus 2. There's one important bit of information. And x plus 1 is a factor. There's the other important bit of information. Okay, so if we have a remainder of negative 18 when divided by x minus 2, that's because p of 2, which is how we find the remainder when we divide by x minus 2, is equal to negative 18. If x plus 1 is a factor, that means that p of negative 1, which is how we calculate the remainder when we divide by x plus 1, and if it's a factor, the remainder will be 0. Okay, so there's our two bits of information. Alright, so p of 2 is equal to 2 cubed plus a times 2 squared plus b times 2 minus 12. You might like to write a bit small here. We're going to have a bit of working, I think. And we know that that's going to equal negative 18. So let's just tidy this up, this equation up a bit. So we're going to have 8 plus 4a plus 2b minus 12 equals negative 18. Okay, so that is 4a plus 2b. 8 minus 12 is negative 4. So it's 4a plus 2b equals negative 14. So adding 4 to both sides there. And then everything's even here, so let's divide by 2 while we're at it. Okay, so 2a plus b is equal to negative 7. There's an equation. Let's create another equation with the other bit of information. So we know that p of negative 1, so that is negative 1 cubed plus a times negative 1 squared plus b times negative 1 minus 12. We know that has to equal 0. So negative 1 cubed is negative 1. Negative 1 squared is positive 1, so that's just plus a. B times negative 1 means minus b, and minus 12 equals 0. Okay, so we've got a minus b minus 13 equals 0. So that is a minus b equals 13. There's equation 2. Alright, so here's our simultaneous equations that we now want to solve. Okay, so we can use elimination here. We can easily eliminate b by adding the two equations. Okay, so we're going to do equation 1 plus equation 2. And when we do that, 2a plus a gives us 3a. B plus negative b eliminates, that's the point. Negative 7 plus 13 is positive 6. And so a equals 2. And then we can sub a equals 2 back into either of our equations. So let's sub that into, I'm going to go into equation 2, which is a bit nicer. So we get 2 minus b equals 13. And so negative b equals 11. And so b is negative 11. So if a was 2 and b was negative 11 in the original polynomial, we would have found we had a remainder of negative 18 when we divided by x minus 2, and no remainder when we divide by x plus 1, which is because x plus 1 is a factor. Alright, let's look at one more example to finish off. Find the values of a and b that make 2x cubed plus ax minus 13x plus b exactly divisible by x squared minus x minus 6. Okay, this is a bit trickier. So exactly divisible, that definitely means no remainder. But this isn't linear. Okay, so we've only learnt factor theorem and remainder theorem when we're dividing by something linear. Okay. However, if when we divide by x minus 2, so let's think about something. If you know that, let me pick another number. If we know that 36 is divisible by 12, we automatically then also know that 36 is divisible by 2, because 2 goes into 12. It's divisible by 3, because 3 goes into 12. It's divisible by 4, because 4 goes into 12. It's also divisible by 6, because 6 goes into 12. So what we want to think about here is that x squared minus x minus 6, we can factorise that into two linear expressions. Factors of negative 6 that add up to negative 1, so that's x minus 3 times x plus 2. So if it's divisible by x squared minus x minus 6, that means it's divisible by x minus 3 times x plus 2, which means it's divisible by x minus 3, and it's also divisible by x plus 2. Okay, so divisible by, we know that we're divisible by x minus 3, which will mean that p of 3 is equal to 0, and we're also divisible by x plus 2, which will mean that p of negative 2 is equal to 0. Okay, so you want to think about breaking down your quadratic factor so that you get two linear factors, and then you know that the polynomial is divisible by both of those linear expressions. Okay, so we know that p of 3 equals 0, so let's work out p of 3. So 2 times 3 cubed plus a times 3 squared minus 13 times 3 plus b, we know that has to equal 0. So 3 cubed is 27 times 2 is 54. 3 squared is 9 times a. 13 times 3, 39. And plus b. We know that equals 0. So again, let's tidy this up a little bit more. So we're going to have 9a plus b. And then we've got 54 minus 39, which is 15. And so it'll be equal to negative 15. Okay, so there's our first equation. So p of, the other one was p of negative 2 equals 0. So p of negative 2 is 2 times negative 2 cubed plus a times negative 2 squared minus 13 times negative 2 plus b. And we know that equals 0. Let's tidy this up. So negative 2 cubed is negative 8 times 2 is negative 16. Negative 2 squared is positive 4. Minus 13 times minus 2 is plus 26, and then plus b. Okay, so what have we got here? 4a plus b so we've got negative 16 plus 26, so that's positive 10. When we move it over to the other side, it'll be negative 10. Okay, so we've got two equations. Now, again, we've got a nice like term here that's going to eliminate very nicely. So this time we're going to need to subtract them in order to eliminate. So we're going to do equation 1 minus equation 2. So 9a minus 4a is 5a. b minus b, they eliminate. Negative 15 minus minus 10 is negative 15 plus 10, and so that's negative 5. And so a is negative 1. And then we can sub a back into either of those equations. I'm going to go into equation 2 again. The numbers are a bit smaller. So it is 4 times negative 1 plus b equals negative 10. So it's negative 4 plus b equals negative 10. Adding 4, b is going to be negative 6. Alright, so therefore a is negative 1 and b is negative 6 if x squared minus x minus 6 is to be a factor of the polynomial. Okay, so some practice here for you to do from exercise 10G in your textbook.